Today we're going to discuss the problem number 28.68 from the chapter 28 to the test 3. So basically the problem states a circular loop has radius r and carries current I2 in a clockwise direction, which is presented on the figure 28.68 to the right side. The center of the loop is a distance d above the long straight wire. And the question is, what are the magnitude and direction of the current I1 in the wire if the magnetic field at the center of the loop is 0? So basically, to solve this problem and to answer this question, we have to define the equation of the field at the center of the loop, which is basically going to be P equal mu 0 multiplied by I1, current I1, and divided by 2R. We know that it's a long wire, so we can write it as mu 0 multiplied by I1 divided by 2 pi d, and d is a distance. D is the distance above the long straight wire. This was the equation for the long wire as B1, for example, and we can define the same equation for the loop, which is going to be B2 equals mu 0 multiplied by current I2 divided by 2R. So to find the magnitude of the current I1 in the wire if the magnetic field is 0, we have to make these equations equal in the magnitude. So basically, we take both of these equations and make them equal. And to find the magnitude of the current I1, we just need to simply define I1 as another equation, which is basically going to be current I2 multiplied by pi multiplied by d and divided by r, which can be represented as almost the same equation as pi d over r multiplied by the current I2. So basically, this is the answer for the first part. This is the magnitude of the current I1 in the wire if the magnetic field at the center of the loop is 0. The other part we have to answer is the direction of the current I1 in the same wire if the magnitude of the loop is 0. And basically, having this equation, having this information that was given initially, we can simply state that the direction of current I1 is towards right in straight wire. So basically, it points to the right side. So the answer for the for this problem is the magnitude that we find, which is current I1 equals pi times d over r multiplied by 2, and the direction of the current I is and the direction of the coin I points to the right side. So this is the answer for the whole problem, which we solved.